it in mode 0, I have to give it as 0. To operate it in mode 1, I have to give it as 1. Since the question says make port B operate in simple IO mode, I have to make it as 0. Next, D3 is what? PC upper, port C upper. Now what port C upper I have to make? I have to make it as again output port, port C upper in output port. So this is also 0 output port. And then D4 is the IO function of port A. Port A, what I have to make? Input port. So that is 1 input port. And port C lower, port A, in which mode I have to operate? Again simple IO mode, 0 0. And this is always 1. Now when I take this is hexadecimal equivalent is 92, because this is 1 0 0 1. This is 9 and this is 2 2. And similarly I have one more example here. Write control word for simple IO mode for making port A as input, port B as output, port B as output port, port C upper as input port, and port C lower as output port. Observe here. Now port C lower, this is port C lower. Now what does that have to do? I have to make it as output. So I have made it as 0. Next, IO function for port B. Now port B I have to again port B, see what is I have to make it as output port. So made it as 0. Here we are using port B as input port, it was 1. Now I want to use port B as output port, it is made as 0. Next, T2, mode selection for port B. Now port B, which mode I have to use? Simple IO mode, hence it is 0. Now if it says use port A and port B in the strobed IO mode, then this should be what? 1. Next, what is the next one? D3, port C upper, what is that I have to do? Port C upper as input. So it is 1. It is 1. This bit, port C upper as input, hence it is 1. Next is port A. Again it says port A as input port, made as 1. And port A I have to operate in which mode? Simple IO mode, 0 0. And this is always 1 for input output mode. So 0 0. If the question says operate port A in strobed IO mode, then I have to give it as 0 1. 0 1. If the question says make port A to operate in the bidirectional mode, then 1 X. This can be 0 or 1, anything. It can be 1 0 or 1 1. Now I hope you understood this example. And next I have example on the bit set reset mode also. So D7 is 0, that means we are operating 8255 in bit set reset mode. Here. Control word, write the control word for setting 5th bit of port C. I want to set the 5th bit of port C. Now this I have to make it as 0 because I want to control word. This bit should be made as 0 and these are don't care, XXX. Now which bit I have to make set the 5th bit of port C, 1 0 1 5 1 0 1. So this is 5th bit, and what is that I have to do? I have to set it. So 1. What it will do? Now when I put this value to the control register, it will set the 5th bit of port C. 5th bit of port C will be made as 1. And similarly, how do I reset the 5th bit of port C? It's same. So 5th bit, I have to reset, right? Make D0 as 0. Now one more example. I have control word for setting the 4th bit of port C. Now which bit I have to set? 4th bit. 1 0 0 4. 4th bit to 1. Similarly, how do I set the 7th bit of port C? 1 1 1. This is 7 to 1. This is how you can do it. The examples, and this explains how to interface 8255 with a 8-bit microcontroller or processor. Now this is 8255, so we call it as 8255, but its name is 82C55A. So but you can always call it as 8255, which is a programmable interface device. Now we are interfacing this 8255 with the processor or the controller. Now, and this processor or the controller, we are assuming it is an 8-bit processor or controller. When I say 8-bit, the database has only 8 lines, because at a time you can access only a byte. Whereas the address is what? Address of this is 16. It has 16-bit address. It has 8-bit data line and 16-bit address lines. And now when I'm connecting, this processor or the controller, 8-bit controller to 8255C, now this is what I do. Now since it has 16 address lines, now just to save the pins, what we are doing here is we are using this latch. In order to using this latch, I'm multiplexing the data lines also and the lower 8-bit address lines. Now there are 16 address lines here. Now I'm using this latch in order to multiplex the data lines D0 to D7 and address lines A0 to A7, and the remaining address line A8 to 815 directly goes to this address decoder and connected to pin 6 of 8255. The data bus D0 to D7 are connected to pin 27 to 34 of 8255, and here the lower address lines A0 to A7, A0 is connected to pin 9 and A1 is connected to pin 8, and A2 to A7 comes to this address decoder and then connected to pin 6. With this you can save a lot of pins, and as I told already, this 8255 has 3 ports, port A, port B and port C. PA0 to PA7, totally 8 bits, 0 to 7, 8 bits, P0 to PB7, PC0 to PC7. Only thing is this is divided into 2 groups, port C lower and port C upper. PC0 to PC3 is port C lower, PC4 to PC7 is port C upper. So this port can operate only in simple IO mode. So port A can operate in 2 modes, that is simple IO mode also and strobed IO mode also, or handshaking IO mode also, and port A can operate in all the 3 modes, that is simple IO mode, strobed IO mode and the bidirectional IO mode. Hence there are 2 bits reserved in the control word register for specifying the mode of port A, that is D6 and D5, and there is only 1 bit reserved to specify the mode of port B. Because it operates in only 2 modes. To specify 2 modes, only 1 bit is sufficient. So 0, if you make which bit it is mode selection for port B is D2. If you make D2 as 0, it operates in simple IO mode. If you make D2 as 1, it operates in strobed IO mode. And there is no bit reserved to specify the mode of port C, because it always operates in only 1 mode, that is simple IO mode. Yeah. So that this completes the sensors and actuators full. And next topic will be on the data communication part. So till now you understood the input devices for the embedded systems and the output devices for the embedded system. And the next thing that we discuss is the data communication part. There is lab program on the keyboard also. So this simple program, sample program I explained, there is a lab program on the keypad. Now you'll understand how to interface this keypad with the microcontroller, and you're going to display the key which you press from the keypad. That lab program is there. There again I'll explain the program in detail. And you have one lab program on push button also. What program it is? When you push press the push button, LED glows, and similarly when you press the same push button for the second time, LED goes off. Alternatively it happens, and that is the program logic which does it. You'll understand the program there. And yeah, buzzer is there? No, then there is no lab program on the buzzer. And stepper motor also there is a lab program. We in the lab program we make the stepper motor operate in the wave step. That is you're going to energize the coil. If you want to make the stepper motor rotate in the clockwise direction, you'll energize the coils in this fashion. First coil A, next coil B, next coil C, next coil D. It rotates the stepper motor in the clockwise direction. And if you energize in the reverse order from D, C, B, A, it rotates in the anti-clockwise direction. Now in my next sessions I'll be explaining the programs also, the all these lab programs. Only thing is I cannot show you the execution. As much as possible, wherever I can show you through the simulation, I'll try to show you. But the execution requires the stepper motor hardware and all. The moment you are back to the college, I'll execute them, but the logic and all I'll be explaining as much as possible through the recorded video sessions. Yeah, you don't have anything on optocoupler. Yeah, and you have lab program on the 7-segment display also. 7-segment display also. That also I'll explain. And then yeah, and do you have any lab? Yeah, a light emitting diode. This is what this push button and light emitting diodes are connected together. When you push the button, the LED glows, and when you push the button, LED again same push button. If you press for the next time, the LED goes off. That lab experiment is also there. Now we'll discuss all those things at a later point of time when I cover the lab things. I'm planning to cover even the lab part B lab programs also through the recorded video session. The moment I do, yeah, I'll record the videos and share with you people. Yeah, we'll finish the today's session here. I hope you understood all these output devices. The first thing that we understood was the piezo buzzer, and the second thing that we understood was the simple push switch, and the next thing that we understood was a keypad. I hope you understood the keypad, how to identify which key you have pressed from the keypad. So the technique that is used here is the scanning technique. So initially we make all the columns as I, and then whenever I press columns as I and rows are made as 0. Whenever I press any push button, the corresponding column will go 0. And when the column goes 0, I can know that I have pressed some key from that particular column. Next, to identify in which row I have pressed, correct, right? So I'll energize one row at a time. I repeat this until the corresponding column again is made I. The moment it goes I'll come to know that. So that is the particular row in which I have pressed the key. So after this keypad, you understood 8255, which is a programmable peripheral interface device. Why it's called programmable? Because you can make a port A, port B and port C either as input or output port by setting the bits and the control word register. And you know control word register is how many bit register? It is an 8-bit register. So that format you have to remember. What format? So this format you have to remember. Now what is this bit is, what is this bit is, what is this bit is, all these things you have to understand. You practice them 1 or 2 times and try to remember. Yeah, I'll finish the session for today. I hope these examples also you understood. Thank you. We'll continue in the next class.